Hello students, today we are going to discuss about the physics first chapter of class 9, that is motion. So students, you have already read it in the class 6 and 7, what is motion, and there you read it motion and measurement and motion with respect to time, motion and time, this way. Now we'll read details about the motion. So first of all, what do you mean by motion? That means, see there, I wrote it. A body is said to be in motion if its position changes continuously with respect to a stationary object taken as a reference point and also with respect to time. Okay, what do you mean by that? Means a body changes its position continuously. One body changes its position continuously with respect to a stationary object. This stationary object means an object is at rest. The rest object can only taken as a reference point. Suppose this is a point and you know that this is the stationary and this is the road. This is the road. Suppose here in this road we are going through a we are going through a bike, or suppose this is a shop, sweet stall. Okay, so what happened here? Now suppose someone started a started from here and moves in this direction towards B. Okay, someone you started from A and moves here to B, and when you are here you are just behind. Suppose this is the shop, you are just behind the shop, and when you are here now at this position, you are at the at this position you are just behind the shop. Here you are suppose the shop is faced towards here, that means at this position you are left, you are present left side of the shop, and here in front of the shop, and here that means you are in the right of the shop. That means when we are taking this as an stationary object, this shop, then the position of one object is said like this. This is the position A, this is the position B, and this is the position, suppose this is a C, this is the B, and it changes continuously. The position changes continuously, that is called as motion. Okay, so then we'll come to the one new phenomena. You know that is the what is the scalar quantity and what is the vector quantity in the previous classes. I have told you. Now I am telling about the distance. The distance. What do you mean by distance? So distance is the actual path. It is the actual path traveled by an object during its motion. During its motion. The actual path traveled by an object during its motion is called distance. During its motion, okay, it's called distance. That means distance is the actual path traveled by an object. Okay, then it is denoted, distance is denoted by S. You will read it. It is denoted as a symbol S. And all the distance, suppose length of body, means suppose we will ask what is the distance from Tikavali to Kandhamar. That means we are telling 35 kilometer. That's the kilometer, meter, these are the units. But units are units of distance are, what are the kilometer, meter, centimeter, millimeter, etc. These are the units of distance, but the SI unit, of distance, the SI unit of distance is meter. That is meter. We can say this is the SI unit of the distance. Okay, then we'll come to the clear cut instruction. See there, suppose this is a position A, or this is Tikawali, this is Tikawali, and this is Bhubaneswar. Suppose someone went in this way through the Khajripada, Daspala, via Daspala to Bhubaneswar. Suppose that is 240 kilometer. Okay, suppose this path is traveled by A, and someone went through this, that is the Bhanjanagar, via Bhanjanagar to Bhubaneswar. Suppose that is 220 kilometer. Suppose that is traveled by B, and someone suppose went through the to Fulbani. This is the route to Fulbani. Then again in this way, same as this. Then this is suppose C, which is equal to suppose 260 kilometer. Suppose that is 260 kilometer, and here we know that is the actually air traveled. Suppose what is the distance between this and this? Suppose this is the distance. Suppose this is the shortest distance, which is suppose 180 kilometer. But here the actual path traveled by C, the path, actual path, or we can say distance traveled, distance by A, that is 240 kilometer. Similarly, distance traveled by B is equal to 220 kilometer. Distance traveled by C, that is 260 kilometer. So these are the various distances traveled by A, B, and C. Now we'll read about, suppose distance is which type of quantity. This is the actual path traveled by this, whatever it may be. Okay, which type of quantity? The distance is a distance is a scalar quantity. It is a scalar quantity. Why we are saying this is scalar quantity? Because see there, suppose this is the distance, and here it has no direction. Suppose here this travel to this here, it has no particular direction. That's why distance is a scalar quantity, and the distance traveled by an object never become zero. Distance never become zero. Okay, distance never become zero. Then now we'll come across displacement. This is the distance we read it. Then displacement. What do you mean by displacement? So first of all, displacement means that is the shortest route that may not be traveled by the object, but this is the shortest route drawn from the initial position drawn between the initial position and final position of an object during its motion. This is the displacement. Okay, so first of all, what do you mean by displacement? That is it may not be traveled by the object, but this is called as displacement. Suppose this is the point A and this is the point B, and suppose I told you that is this path is traveled by A, this path is traveled by B. Suppose this is Tikavali and this is Bhuvneshwar. Okay, so here is this is 240 kilometer, this part is 220 kilometer, and another part of C, that is traveled by C, that is 260 kilometer. And here this is the shortest route. Okay, here shortest route drawn between the initial point and the final point. This is the shortest route, which is equal to 180 kilometer. This is called as displacement. It may not be traveled by the object. Okay, so we'll read more about the displacement in the higher classes. We'll read this as different. So displacement is denoted by S arrow. See there, why it is denoted by S arrow? Because it has one direction, that is Tikavali to Bhubaneswar. This is direction, but here the direction changes. It does not depend on the direction. Distance does not depend on the direction. That's why distance is a scalar quantity, because it has no direction. But displacement is a vector quantity because it has a means it has a direction. We can say displacement is denoted by S arrow, or in your class you will read about only S. Okay, then displacement is a vector quantity. Which type of quantity is this? It is a vector quantity. Displacement is a vector quantity, and displacement can be zero. Displacement can be zero. When the displacement is zero? When the initial point and final point are same. In this case the displacement become zero, because see there, I told you, suppose one object started from here and again return from here to there. So okay, so here A to B, again it goes from A to B, that is 200 meter, and again return to A. Okay, then what is distance? The distance can be A to B 200 plus 200, that is the distance, which is equal to 400 meter. But what is this displacement? Displacement S arrow is equal to 0 meter. Why I am saying 0 meter? Because the initial point and the final point is same, and you know that the shortest path between the initial and final point, as initial point is A and final point is A, and that shortest path is 0. So that's why in this case, in this case the displacement can be 0. Okay, then next is the unit. The unit of displacement is same as distance. The unit of displacement is same as the distance. Okay, so this is all about the distance and displacement, and finally we get it, that is the, suppose this is the distance and this is the displacement. It is scalar, it is vector. It is the definition, it is the actual path traveled by an object, it is the shortest path traveled by an object. That means it is a scalar, means it has no direction but magnitude, but it has magnitude as well as direction. Okay, then the distance never become 0, the distance never become 0, but the displacement can be 0. So these are the some points on distance and displacement. Okay, now we have to do some problems. Okay, so see there, suppose one object, this is the point A, one object moves A to B, that is 4 kilometer, again B to C, perpendicular travel B to C, that is 3 kilometer. The distance is distance travel is equal to 4 kilometer. Actual path, this is the actual path, A to B, then B to C. So 4 kilometer plus 3 kilometer, that is 7 kilometer. But the displacement traveled is equal to, what is the displacement traveled? Now that is the 4 here, this is the displacement. See there, A to C, this is the shortest path, A to C, initial and final, this is the shortest path, and this is equal to, the displacement is equal to AC. We can write displacement is equal to AC, and we can put the Pythagorean triplet formula. What is the Pythagorean triplet formula? This is the H is equal to P square plus B square by root over, that is P is 4 square plus 3 square root over, that is 16 plus 9 root over, that is 25 root over, that is 5 kilometer. This is the displacement. Similarly, suppose one object is going around a circular path, okay, of radius, suppose this is the radius of 14 meter. Okay, so one object is going through this, so what will happen? This is the circular path of radius 14 meter, and when find the distance, suppose in 2 round, the distance traveled is equal to, one round the distance traveled is equal to 2 pi r, but 2 round, that is 2 into 2 pi r. Here s is equal to 2 into 2 pi r, that is equal to 4 into pi is 22 by 7 into r is equal to 14, then that is equal to this. Okay, so you can calculate it, 176 meter. But in this 2 round, what is the displacement? Suppose this is the, suppose here it start, this is 1 and again this is 1, that means initial point and final point remains same, that means displacement will become 0. Okay, so in this way you have to solve this type of question. Okay, thank you.